Now this question is find the value of x for which v is maximum. So basically we are trying to find out the maximum of this equation. So to get the values, we previously in some previous videos also I have discussed, to get the maximum or minimum value we just need to calculate the dv dx, or we can see v dash to be equals to 0. If it is to be 0, then we have already calculated, let me just give here the number, that is c, and for d1 we are trying to find out the result. So dv dx equals to v dash equals to 0. So dv dx is to be 0 for the critical points, and maxima, minima and inflation points all are in the critical point region. So to find out the critical point, we will need to find out dv dx to be equals to 0. So from here we are getting dv dx to be 0. So the point is 72x minus 36x square is equals to 0. From here we are getting 72x. So just we need to calculate this portion. So after calculating we can have to be if I taking common x, so 72 minus 36x equals to 0. So either x equals to 0 or x equals to 2. Either x equals to 0 or x equals to 2. So from here you can find out, you can see that at x equals to 2 it will have the maximum value. At x equals to 2 it will have the maximum value. Again, how you will find out this particular fact, at x equals to 2 it will have the maximum value or not? Just you do the dv dash dx. If we do dv dash dx, we are getting it to be like ddx of, just a checking, I am doing just a checking, ddx of dv dx. So if we double derivate that, so it will come 72 minus 72x. Ultimately it will be there. And if you put the value at x equals to 0, d2 dx, just see the particular fact. At we have two critical points, x equals to 0 and x equals to 2. So at x equals to 0, so v double dash at x equals to 0, v double dash at x equals to 0 is 72, that is greater than 0, and v double dash at x equals to 2 is 72 minus 72 into 2, it is basically minus 72, so it is less than 0. So at v double dash is pointing out at 2 is less than 0, that's why at x equals to 2 the function will have the maximum value. It will have the maximum value. We have checked that from the double derivative. So find the value of x for which v is maximum. So the value of x is 2. We have found out this from the double derivative principle. Okay, now we have to justify the answer. To justify the answer, let me just draw a graph for you. I just want to justify my answer. So this is the graph, and somehow this is the graph is there. This is the graph. So this is the point 2. This is the point x equals to 2. Now if I take 2 point, this is x equals to 1 and another point x equals to 3, I just need to find out the dv dx at that particular point. So dv dx at x equals to 1 is, dv dx is, you can see 72x minus 36x squared, so x equals to 1, it will be 72 minus 36, that is 36 greater than 0. So here we are having the positive slope, and again we are trying to calculate dv dx at x equals to 3, it is coming out to be 72 into 3 minus 36 into 9. So basically here 216 minus 324, so it is less than 0. So here we are having the negative slope. It means particularly at x equals to 2 we have the highest order. So that's why the answer is justified. To justify the answer, you just need to take 2 points. One is below the critical point, another one is above the critical point, and you need to calculate the dv dx. Okay, so again I am recapping the particular part, that is find the value of x for which v is maximum. Okay, so to find the value of v is maximum, we have the first derivative in our hand. So if we calculate the first derivative to be 0, we are getting two critical points, one to be 0, x equals to 0, and another is x equals to 2. Now how we will find out whether in these 2 points which point is the maximum, which point will give us the maximum value? For that we need to check the double derivative. That's why I have taken the double derivative, that is v double dash. Now at x equals to 0, v double dash is greater than 0, and at x equals to 2, v double dash is less than 0. Always remember this fact, if v double dash is less than 0, at that particular point the function will have the, at that particular critical point the function will have the maximum value, and at x equals to 0 the function will have the minimum value. Okay, so this is the fact. Now find the maximum volume. This question is very easy. Find the maximum volume. To get the maximum volume, we need to have the particular value of the x for which the value will be maximum. So this is again a very simple question. So for E, we know that at x equals to 2, v is maximum. At x equals to 2, v is maximum. Okay, if we put x to be 0, then v is max. Now the formula of v in terms of x was, formula of v in terms of x was 36 x square minus 12 x cube. In the previous slide you can see that. Now so 36 into 2 square minus 12 into 2 cube, so it is basically 36 into 4 minus 12 into 8, so it is 144 minus 96, so it is 48. So the maximum volume is 48, and the unit is in written as centimeter, so 48 centimeter cube, so it is centimeter cube. Always try to put the limits in hand, so it is 48 centimeter cube. Okay, so in this way the complete problem is solved. Thank you for watching IB360. In next video the rest two problems will be solved. Thank you for watching.